Dear students, you are mostly welcome to academic research for OJEE 2019 PGAT electrical possible question and its complete solutions with explanation. So let us start the first question. If the voltage applied to an iron core coil is of the form dt equal to Vm sin omega t, the flux in the core. There are four possible answers, so we have to choose the best suitable answer. So first answer is sinusoidal and leads the voltage wave by 90 degrees. The second is sinusoidal and lags the voltage wave by 90 degrees. And third is a constant value with magnitude proportional to frequency. Is a constant value with magnitude independent of frequency. The best suitable answer is B, that is sinusoidal and lags the voltage wave by 90 degrees. Because already we have sent a sinusoidal voltage, therefore one EMF induced in the iron core, and that EMF produces a current. Due to that current, a flux or magnetic field is produced which is in phase with the current. Therefore, as the current lags to this voltage by an angle 90 degree, therefore the flux also lags by 90 degree and sinusoidal. So answer B is the correct answer. So next question. Ferranti effect on a long overhead line is experienced when it is light loaded, full load, unity power factor, half load, lagging power factor, full load, lagging factor. So Ferranti effect, you should know what is called Ferranti effect. That is the increase in voltage occurring at the receiving end of a long transmission line above the sending end. So it means when the receiving end voltage is more than sending end voltage during energization of a long transmission line at no load or light load condition is called Ferranti effect. It means if we load a long transmission line at no load condition or light load condition, in that period the receiving end voltage is more than sending end voltage. Sending end voltage. So this effect is called Ferranti effect. So therefore the is the correct answer, that is light loaded. So A is the correct answer is A. The voltage regulation of a transformer mainly affected by no load current and load power factor, winding resistance and load power factor, leakage flux and load power factor, winding resistance and core loss. So let us see the answer. So voltage regulation, already we know that is I into R e2 cos phi plus x e2 sin phi divided by V. So here cos phi means the power factor. So generally it is more affected by, therefore winding resistance and load power factor. So the voltage regulation mainly affected by winding resistance and the load power factor. So answer B the correct answer. So next question. So a 2 kVA transformer has iron loss of 150 watts and full load copper loss 250 watts. The maximum efficiency of transformer occurs when total loss is 500 watts, 400, 300 to 75 watts. So First, we should know when the maximum efficiency of a transformer occurs. So the condition is when variable losses is equal to constant loss. So the maximum efficiency occurs. So then here the iron loss is 250 watts. This is the constant loss, and copper loss is the 250 watts. This is the variable loss. So this loss is always constant in a transformer. That is iron loss is called constant loss, and it is independent of any load condition. Whatever the load condition in a transformer, the iron loss is always constant. Therefore, it is called constant loss. Therefore, this should not be changed. So, our condition is the maximum efficiency occurs, that is, the constant loss is equal to variable loss. Therefore, the constant loss is always constant. Therefore, this 150. So, the copper loss also 150. We cannot make it 250 because this is variable losses. So, therefore, total losses is equal to 2 into 150, that is 300. Because we have to only multiply 2 with constant loss, because it is always constant. So, answer C is the correct answer. So, next question. Force of a large transformer built of nearly circular cross section in order to reduce leakage, reactance, iron loss, copper loss, eddy current loss. So the best suitable answer is copper loss, because copper loss is nothing but that is I square R loss, that is depend upon resistance. So when the cross section is, instead of taking a rectangular cross section, if we take the circular cross section, the resistance will be less and copper loss will be less, because area of cross section of circular cross section is less. So answer C is the correct answer. So next question, a 230 by 2300 volt transformer takes no load current of this and observes 8 watt. If the resistance of primary is this, what is the core loss? So let us see the answer. The primary copper loss is equal to I naught square R1, that is no load current, the square of no load current, that is 6.5 into 6.5 into resistance of primary, that is 0.062.5 watt. Iron loss is equal to no load power minus primary copper loss. So no load power already given, 187 minus 2.5, that is 184.5 watt. Therefore, the answer B is the correct answer. Next question, carbon buses are used in this machine because due to high contact resistance, it acts as a solid lubricator. It is a conductor with a good mechanical strength. All of the above. So answer all of the above is correct, because the carbon is a high resistive material, so that there is if the resistance, as the resistance is high, the commutation become a good commutation. Due to good commutation, no sparking occurs. It also acts as a solid lubricator, that is the wear and tear uh, is very less, that is friction is very less. It also acts as a conductor by which we can send the current to the load circuit. Therefore, all of the above is correct. Next question, hysteresis losses in a DC machine is directly proportional to speed, that is square of speed, then speed to the power 1.6, none of the above. So already we know that hysteresis loss is directly proportional to frequency, which is directly proportional to number of poles and speed divided by 120. Therefore, the pH, that is hysteresis loss, directly proportional to speed. So answer A is the correct answer. Therefore, it is directly proportional to speed. In a DC generator, the main function of compensating winding is to reduce the demagnetizing effect of armature reaction, to reduce the distortion effect of armature reaction. So answer B is the correct answer, to reduce the distortion effect of armature reaction. So voltage regulation of a DC generator is zero. This implies that the generator is flat compound, differential compound, short mode series. Zero voltage regulation means the full load terminal voltage equal to no load terminal voltage. This is possible by flat cumulative compound generator. Therefore, answer A is the correct answer. So, for successful parallel operation of two single phase transformer, the most essential condition is that percentage impedance are equal, polarities are properly controlled, ratio are exactly equal, KVA ratings are equal. So answer D is the correct answer, that is KVA rating are the equal. This is the most suitable answer. Next question. The voltage regulation of transformer at full load at point 8 2.5 and voltage regulation of full load point 8 power factor leading will be 0, because 0 voltage regulation is possible only with leading power factor. Therefore, answer B is the correct answer. Then, if the frequency of input voltage of transformer increase, keeping the magnitude of voltage unchanged, then both hysteresis and eddy current losses increases. So let us see the question. Sorry, uh, answer. If the frequency of input voltage transformer increase, keeping magnitude of voltage unchanged, so voltage remains same, but if we increase the frequency, then what will happen to hysteresis and eddy current loss? Let us see the solution. So already we know that the hysteresis loss is equal to hysteresis constant into frequency into maximum flux density to the power 0.6. Similarly, eddy current loss is equal to eddy current constant into f square, that is square of the frequency, then square of the maximum flux density. So this is the formula for uh, hysteresis loss, to calculate the hysteresis loss, and this is for eddy current loss. But already we have there is another condition, we have to maintain the voltage constant. It means this must be constant. Therefore, if frequency is increased while voltage remains constant, so Vm decreases to maintain the voltage constant. If frequency increases, then Vm must be decreases, because this is all others are constant. Therefore, in these two must be vary. So Bm will decrease, but F and Bm remains constant. So eddy current loss. So eddy current loss. Eddy current loss. P remains unchanged. Therefore, pH1 by pH2, PM1 by PM2 by 0.6, which is equal to F1 by F2 to the square. So when frequency increases, so the pH that is uh, hysteresis loss increases when frequency increases, hysteresis loss increases. So next question, a 100 kVA transformer so sorry for the interruption. A 100 kVA transformer has copper loss of 1000 watt at full load and iron loss of 1000 watt at half full load, lagging the efficiency of the transformer nearly. So let us see the answer. So copper loss at half full load. So already we have given copper loss at full load. Therefore, half full load that is x square PC, that is here x is 1 by 2, so 1 by 2 square into PC, that is 100 by 4, 0.25 kilowatt. So output at half full load 0.8 at 0.8 power factor is equal to zero point 0.5, that is half into 100 into zero point 0.8, that is 48 kilowatt, because already given that is 100 kVA. Therefore, output is equal to half into 100 kVA into zero point 0.8, that is 48 kilowatt. So input at half load at zero point 0.8 power factor is equal to 40 plus 1 plus 0.25, which is equal to 41.25 kilowatt. So efficiency is equal to 40 by 41.25, that is 96.97. So answer B is the correct answer. So in a DC series motor, if armature current reduced by 50%, the torque of the motor will be equal to 100%, 50% of previous value, 25%. So answer C is the correct answer. Because the torque in a series motor is proportional to the armature current square. Therefore, if it is reduced by 50%, then it is reduced to 25% of the previous value. In a LVDT, the secondary voltage are independent of the core position, vary only equally depend on the core position, vary equally depend on the core position. So answer C is the correct answer. It is equally depending on the core position. So answer C is the correct answer. A transformer will have a zero efficiency at full load, no load. So no load, it will be zero efficiency, because efficiency is equal to output by input. So at no load condition, the output is equal to zero, so efficiency will be zero. So next, open circuit test of a transformer provides information about copper loss, iron loss, total loss, so none of them. So it provides about the iron losses or magnetic losses or no load losses. So answer B, the correct answer. The figure below shows the external VI characteristics of three types of generator having the same rating curve to represent each generator. So this is the three types of generator. So this curve to represents for series DC series generator, because in case of DC series generator, the uh, it is a sharply rises, that is, when load increases, the terminal voltage also increases in a DC series motor. Therefore, this is best suitable for DC series motor. In a DC series motor, if the armature current reduced, the torque of the motor will be reduced by 25% of the previous value. Next, a 3-point starter used to start dash motor. So 3-point starter is generally used to start the shunt motor. So next question, the 3-phase 4-wire energy meter used to measure 3-phase balanced energy only, 3-phase unbalanced energy only, both A and B. So this is answer both A and B is the correct answer. The phase sequence of a three-phase system is RYB. So other possible phase sequence is answer C is the correct answer, that is RBY. So next question. Swans are generally made up of manganese due to low temperature coefficient of resistance. This is the correct answer because when temperature changes, resistance changes very less. So therefore, the error in the instrument is very less. Therefore, manganese is used as the source. A small stamping resistance put in the series with the operating coil of moving coil in order to compensate for the effect of temperature variation, external magnetic hysteresis loss, none of the above. So correct answer is temperature variation. So next question. At parallel resonance circuit, the impedance is equal to L by CR, LC by R, RL by C, CR by L. Answer A is the correct answer. L by CR is the correct answer. Next question, at the short impedance loading of a transmission line. So the power that can be transmitted is maximum, the voltage profile, the line remains fixed on capacitor, does not play any role, the load becomes highly lagging. So correct answer, it predicts the maximum loading capacity of a transmission line. Therefore, answer A is the correct answer. The power that can be transmitted is maximum. So next question. The speed of a DC shunt motor is practically constant because flux is practically constant because the speed is directly proportional to flux. Therefore, the DC shunt motor is practically a constant speed motor. A DC series motor generally used where speed is variable. Speed is constant, any speed, that is answer A is the correct answer, speed is the variable. Because DC series motor is a variable speed motor. So next question, DC series motor are used where high starting torque, constant is low load. No. So answer is the correct answer where high starting torque required because DC series motor having the highest starting torque among all the motors. The cumulative compound motors are used where variable speed is required. Suddenly heavy loads for short duration. So B is the correct answer where suddenly heavy loads for a short duration is required. In that case, cumulative compound motors are used. If the frequency of three-phase supply to stator of a three-phase induction motor increases, then synchronous speed also increases because Ns is equal to 120 by P. So therefore, when frequency increases, synchronous speed increases. If Ns is the speed of rotating flux in the speed, then the rate at which flux toward the rotor conductor, that is N minus Ns. Sorry, Ns minus N is the correct answer. voltage called slip speed. It cuts the rotor conductor at slip speed, that is ns minus n. The synchronous speed of the three-phase induction motor having 20 poles and connected to 50 volts. So that is correct answer is ns 128 by 300 rpm. The relationship between synchronous speed ns, rotor speed n, and slip s is equal to n is equal to ns into 1 minus s. Therefore, B is the correct answer. Can the rotor of a three-phase induction motor block the slip is equal to 1? Block means it is stationary condition. Stationary condition means rotor speed is equal to 0. Therefore, slip is equal to ns minus n by ns. So, n is equal to 0, ns by ns to 1. The starting torque of a three-phase induction motor is maximum rotor resistance per phase is equal to rotor reactance, that is R2 is equal to X2. The torque speed characteristic of three-phase induction is similar to DC series motor, DC sound motor, compound motor. So DC sound motor, the torque speed three-phase induction motor, also DC sound motor. So next, the three-phase induction motor can be compared to a power transformer whose secondary is short-circuited, because in case of three-phase induction motor, the conductors are permanently short-circuited, their end rings, and at the stationary it is short-circuited. Therefore, it can be compared to a power transformer when its secondary is short-circuited. If the air gap between rotor and stator of three-phase induction motor increases, then no load current decreases, leakage reactance decreases. So answer is leakage reactance increases because when air gap increases, it opposes the magnetic flux because reluctance of air gap is high, therefore leakage reactance increases. The rotor of a three-phase induction motor always rotates in the direction of rotating magnetic field. According to Faraday's laws of electromagnetic induction, Lenz's law, Ampere's law, and some. This is according to Lenz's law because due to rotating magnetic field, the EMF is induced, and that produces a current. That current produces a torque. Therefore, uh, according to Lenz's law, it always opposes the direction of rotating magnetic field. The direction of rotation of three-phase induction motor can be reversed by interchanging any two supply terminals of the stator. Answer A is the correct answer. The purpose of starting winding is a single-phase induction motor is to reduce losses, to reduce temperature, to produce rotating flux. Answer C is the correct answer. In the resistance split-phase induction motor, the main winding has high resistance, high inductance, high resistance, low inductance. Answer C is the correct answer, low resistance and high inductance. A single phase fully controlled rectifier has 300 sine. It will have average output voltage for higher angle of 30 degrees. So 270, 178, 276. So let us see the correct answer. Vm is equal to 300 volt. Here maximum voltage 300 volt alpha equal to 30 degrees. So V average Vm by pi into 1 plus cos alpha, 300 by pi into 1 plus cos 30, that is 178.19 volt. So answer is B is the correct answer, that is 178.19 0.8 approximately. So, totemple configuration used in the gate drive circuit for a power BJT is to sink current from load to ground. To stabilize the circuit, to fire the circuit, none of the above. So answer is the correct answer, sink current from load to ground. A three-phase sine PWM inverter operates from a DC link voltage of 400 watt will be the RMS magnitude of fundamental line voltage for modulation index 0.87. So let us see the answer. This is a very simple. That is V is equal to M root 3 Vs by 2, where M is the modulation index, root 3 source voltage divided by 2. That is V is equal to 0.8 root 3 into 400 by 2. That is 277.12 volt. So answer C the correct answer. Advantage of bipolar switching over unipolar switching. A pair of unwanted harmonics can be eliminated. Fast switching power consumption is none of the above. So answer A is the correct answer. That is a pair of unwanted harmonics can be eliminated by using the bipolar switching over unipolar switching. So COP converter better than buck boost converter because makes ripple current zero. No need to filtering noise current, no need of output filter, capacitor, all of the above. So answer D is the correct answer, that is all of the above is correct. dV by dt rating is important for a power semiconductor switch because the SCR can be turned on automatically without gas signal which is unwanted. So answer A is the correct answer. This is very dangerous, therefore this is not required, which is unwanted. So therefore we should know dV by dt rating of a power semiconductor switch. Answer A is the correct answer. A snubber circuit is designed as follows: a series combination of resistance and capacitance in parallel with thyristor. So A is the correct answer. It is a series combination of resistance and capacitance which is connected in parallel of the thyristor. So next question. The unity step response of a unity filter system with open loop transfer function. This is shown in the figure. The value of K is 0. This is very somewhat top question. So steady state error. Uh, Already we should see the figure. This is the figure. So this is the response and this is the time axis. So steady state error actually uh, uh, that is 1 minus 0.75. So because it is the at 0.75 it is lost, therefore it is not touching to 1, therefore error is 1 minus 0.75, so which is equal to 0.25. So steady state error, that is Rs by 1 plus Hs ds is equal to 1 by S by 1 plus K by S plus S plus 1 S plus 2. So limit S tends to 0 S yes. So finally we can get 0.25. Uh, so by solving this, so K is equal to 6 is the correct answer. So next question. This is the given figure. So we have to find out what is the transfer function of this. So I think this question not given. So let us skip this question. Next question, the characteristics polynomial of the system is Qs is equal to 2s to the power 5, s to the power 4, 4s to the power 3, 2s square plus 2s plus 1. It's stable, unstable, marginal, stable, oscillator. Therefore, we have to test this. Whether it is stable, unstable, marginal, stable, or oscillatory. So let us find the characteristics equation. That is, this is the characteristics equation. If we will factorize this, if we will take common 2s plus 1 here, then this will be factorized to these two factors, that is 2s plus 1 and s to the power 4 plus 2s square plus 1 is equal to 0. Therefore, we can find out the roots s is equal to minus 0.5 and here plus j, here plus minus j. Therefore, the highest pair is 4. Therefore, we have got the 4 roots. So these two roots are in the imaginary axis. As the two roots are in the imaginary axis, therefore it is oscillatory in nature. So answer B is the correct answer. If the characteristics equation of a closed loop system is this, the system is underdamped, overdamped, critically damped, and damped. The characteristics equation is this much. Therefore, omega n natural frequency of oscillation is root 2. Comparing with this, the standard second order equation. As we can find out, the damping ratio is 1 by root 2, which is equal to 1, sorry, less than 1. Therefore, so it is under damped. So when it is equal to delta is equal to 1, that is critically damped. When it is greater than 1, that is over damped. Therefore, as it is less than 1, it is called under damped. So next question. The two winding of a transformer is conductively linked, inductively linked, not linked, electrically linked. Solely the transformer windings are electrically separated but magnetically linked. Therefore, B is the correct answer. That is inductively linked. The DC series motor always started with a load because at no load it will rotate at dangerously high speed. Therefore, answer is the correct answer. Next question is ceiling fan index split feed motor, capacitor start and capacitor run motor. So this is the correct answer. J is the correct answer. The bottom of a protected relay means volt ampere rating of the relay. So answer A is the correct answer. So thank you very much. Sorry, some other questions are there. A 50 Hz three-phase induction motor has a full load speed of 40. The number of poles of the motor are 4 because we can find out this because NS is equal to 1 to V here. We have considered NS is equal to 1500 RPM. So answer is the correct answer. The slip of induction machine is 0.02 and stator supply 50 Hz. What will the frequency of rotor induced EMF? That is correct answer is A 1 Hz. Answer C is the correct answer because F2 is equal to SF. S is given 0.02 and F is given 50. So that is 1 Hz. So peak inverse voltage of a diode is the maximum voltage that can be applied across diode in non-conduction direction. So answer A is the correct answer, which is called peak inverse voltage when it is not conducting state. So next question, let us see the. So thank you very much for watching.